What if a single invention could save thousands of lives? From cockpit black boxes to collision avoidance systems, we're counting down the top 10 aviation safety innovations. These breakthroughs emerged from tragedy to transform flying into the safest means of transportation. Like, subscribe, hit that bell to uncover the stories behind the safety you trust. Number 10. Cockpit Voice and Flight Data Recorders, 1953. The 1953 BOAC Flight 783 crash, which killed 43, spurred Australian scientist David Warren to invent the black box in 1958. This indestructible device records cockpit audio and flight data surviving extreme impacts. After the 1960 Trans-Australia Airlines Flight 538 crash, its data exposed critical flaws, prompting global adoption by 1967. Mandatory worldwide, these orange recorders now safeguard 200,000 daily flights. They've decoded countless disasters, from design flaws to pilot errors, driving safety upgrades. While MH370's fate remains unknown, most crashes now yield life-saving units. From solving mysteries to preventing collisions, next, a system born from aviation's deadliest disasters. Number 9. Traffic Collision Avoidance System, or TCAS, 1978. The 1956 Grand Canyon mid-air collision between United Flight 718 and TWA Flight 2, killing 128, exposed the lethal risks of uncontrolled airspace. TCAS, developed in the 1970s and mandated after the 1986 Cerritos crash, Aeromexico 498 versus a private plane, uses transponders to command pilots to climb, descend, or maintain their vertical speed. In 2002, TCAS saved SAS Flight 686 and a Cessna over Milan. By 2020, mid-air collisions dropped 90% post-TCAS adoption. This system transformed chaotic skies into a choreographed network of safety, allowing for higher airspace capacity. Number 8. Ground Proximity Warning System, or GPWS, 1972. Eastern Airlines Flight 401 crashed into the Everglades in 1972 after the crew became hyper-focused on diagnosing a faulty landing gear indicator light, failing to notice their gradually controlled descent into terrain. GPWS, mandated by 1974, uses radio altimeters data and terrain databases to shout "pull up," among other alarms, if a plane nears terrain unsafely. In 1995, GPWS saved 312 aboard American Airlines Flight 965 in Colombia, triggering a last-second climb before mountain impact. Post-adoption, controlled flight into terrain, or CFIT, accidents dropped by 90%. This system transformed complacency into life-saving urgency, ensuring pilots prioritize their trajectory over distractions. Number 7. Crew Resource Management, or CRM, 1978. United Airlines Flight 173's 1978 crash, caused by a distracted crew ignoring fuel warnings, killed 10. CRM, introduced in 1980, trains pilots to communicate clearly, delegate tasks, and challenge errors. You might think it's easy said like this, but in reality it's a very tricky and complicated thing to do in today's hyper-complex airplanes and airspaces. Airlines using CRM saw a 50% drop in accidents by 2000. The psychological shift turned cockpits from hierarchies into teams. Number 6. Enhanced Weather Radar and Wind Shear Detection, 1985. The catastrophic Delta Airlines Flight 191 crash in 1985, killing 137, caused by undetected wind shear, catalyzed the development of advanced weather radar and wind shear detection systems. These technologies provide real-time warnings of hazardous weather conditions based on the Doppler principle, mandated by 1995, enabling pilots to adjust their flight path and avoid dangerous situations. The implementation has drastically reduced weather-related accidents over 99% and saved countless lives by offering early alerts. Number 5. Glass Cockpit Displays. As flight management systems streamlined navigation, pilots still needed clearer, more intuitive information at a glance. After a series of accidents linked to confusing analog instruments, such as the 1985 DC-9 incident, engineers introduced digital glass cockpit displays. These modern interfaces consolidate critical flight data into high-resolution screens, reducing workload and misinterpretation. Today, glass cockpits have been credited with saving lives during emergency situations as pilots gain immediate situational awareness, enabling rapid corrective action in critical moments of flight, truly revolutionizing modern cockpit operations worldwide. Number 4. Fly-by-wire systems with flight envelope protection. While glass cockpits have advanced information display, the need for automated control became clear following loss of control incidents. The devastating United Airlines Flight 232 crash in 1989, caused by engine failure and pilot overload, spurred the development of fly-by-wire technology. This system replaces traditional mechanical controls with electronic interfaces that prevent pilots from exceeding safe flight limits. Its built-in protections have repeatedly averted disasters by automatically stabilizing aircraft during critical emergencies, reinforcing a new era of safety and reliability in modern aviation beyond measure. Number 3. Enhanced Structural Bonding and Inspection Protocols, 1988. Aloha Airlines Flight 243's 1988 decompression, caused by metal fatigue tearing off the fuselage roof, exposed catastrophic flaws in aging aircraft maintenance. The disaster spurred the FAA's Aging Aircraft Program, mandating rigorous adhesive bonding checks and eddy current inspections to detect hidden corrosion and cracks. In 2005, these protocols detected critical fatigue in a Delta 767, grounding it before failure. By 2010, structural incidents dropped 75%. This shift from reactive to proactive maintenance, including ultrasonic testing and improved sealants, turned brittle metal skins into monitored lifelines. Number 2. Advanced Emergency Evacuation Systems. The tragic fire on Air Canada Flight 797 in 1983 exposed shortcomings in evacuation procedures, prompting designers to improve emergency slides, lighting, and cabin layouts. These enhanced systems ensure rapid egress during critical moments, drastically reducing fatalities. Subsequent accidents have demonstrated that faster evacuations can be the difference between life and death. Modern evacuation protocols, refined through rigorous testing and real-life incidents, continue to save lives by enabling passenger exits under pressure. Recent Japan Airlines A350 crash in Tokyo, where all passengers and crew survived, proves these emergency evacuation protocols are absolutely crucial. Number 1. Automatic Dependent Surveillance Broadcast, ADS-B, 2002. In 2002, the Umberlingen mid-air collision, which killed 71, highlighted TCAS limitations. Pilots received conflicting instructions, and transponder gaps left blind spots, allowing collisions to occur. This tragedy spurred the adoption of ADS-B, a GPS-based system that shares real-time location data with nearby aircraft. In 2019, ADS-B prevented disaster over Florida as 2 private jets autonomously adjusted course. Today, over 70% of global flights use ADS-B, reducing collision risks by 80% and addressing TCAS shortcomings effectively, thereby saving many lives.